we'll continue to do the graphical user interface. So last lesson is very, very important. If you skip it, please go back to and rewatch the videos. Mainly the root, we call root, but not necessarily. Basic window is created by calling TK, right? From tkinter module. So by calling TK constructor, you have an object of basic window. There you may have three options. You can populate components, graphical components directly on that basic window, or you can use frame or canvas. If you use a frame, then from frame you can, both ways. Frame can contain canvas. Frame can contain more subframes, which contains in turn subframes. So frame can contain another frame, which contains another and another. So it's hierarchically organized, which means there is a containment hierarchies, right? Graphically, graphically is like that, right? For example, if you have there is entire container like this, very big container, that is called the basic window. Like this. This is a basic window, which can be obtained from TK, right? Uppercase T and small case K and open and close parentheses. Then it construct a basic window, and if you refer to that basic window, then you need to do definitely assign that to some objects, object 1. But in our case, we call it root usually, right? So this is root container. And this root container contains more frames. So this is bottom frame. Bottom frame has other three horizontal the frames. So I call it bottom left, bottom center, and bottom right. That way. So frame needs to be defined. If your frame contains other subframes, and if you want to organize those frames in certain way, then I strongly recommend you to use a grid, so that whole structure will be in this grid format, like tables, right? Like this. So you have rows and column. This is a column. So for example, you have dot grid, and then you can say row equals 0, comma, column equals 1, and so on and so forth, as you wish to assign more values to grid function. Then what it wants to place the components, whatever components here, right, will be row 0, which is here, and then column equals 1, then that will be the second column, because all the index here is counted from 0, so 0 and 1. So actually that is this. So whatever you have here, these components will appear here. Okay, that is what you need to do. So construct a frame and place that frame in the right position by specifying grid function like this. Somewhere, if you have user interface, then you can use entry constructor. In this entry constructor, then user enter some value, some input data. That input data needs to be identified by string var. This is a user interface variable, UI variable. Okay, UI variable. So entry and string var usually go together. And label. Label is very common, so that if you want to write, if you want to show text messages, for example, then you can use label. Or if you want to return any computation result and to display, then you can display in a specific label. So label is very, very common in your graphical user interface programming. Another one is a button. So far, all the components, there is no action involved. Of course, we can do some other way to do action. For example, when you type, when you ask user, so user enter, and the user may be able to hit enter button rather than clicking any specific button. In that way, it should work also. If you want to program yours in that way, then that is also possible. By the way, the next homework assignments ask you to do that. So I'm going to give you. Next, third one. Second one already posted, right? Second one is the extension of I think temperature conversion, right? Converter. Right. So this is the thing that we did. I think we did this last time, right?
Yeah, we did a little bit.
We'll see. This is a homework assignment. Okay? Similar to the way that you design, homework assignments is like that. So you need to have the basic container. The basic container has a top frame and mid frame and bottom frame. Bottom frame, for example, can have 2 subframes. Okay? And if you look at this subframe, then there's 2 tiers, right? This is row 0 and this is row 1. So in the row 0, then you have a button. In the row 1, which is the second row, then you can display the temperature. This is the output of your calculation, and this is like a degree symbol that I already explained in the textbook so that you can get it. If you see the mid frame also has 2 rows. Upper row, we have only the message, say enter a temperature. And then bottom, second row, what is this? What constructor can display text field like this? Label is like this. Label is just display text messages. This is a label, and this is a label, and this is a label. These are the buttons. And what is this? We just looked at slide ago. What is it? In the slide, previous slide.
TK.
No, TK is a basic Windows. Entry can generate a text field so that user can enter here. Okay. So that is the way that you need to do. Here's a little bit of explanation for that. The steps to make this graphical user interface is that here. So that you have first you have to construct a basic window. What is the instructions to create the basic window? TK. Thank you. And then 3 outer frame inside. So outer frame can be called the top frame, mid frame, and bottom frames. So top, mid, and bottom. In the bottom frame, 2 inner frames needs to be declared. So bottom left and bottom right. And then in the basic windows, you need to say string variable y string var open and close parentheses needed. My question to you, why is this needed? Why? I explained that already.
There's a string type for
String type for
the window.
There's a string variable that can, for example, take the value from user interface, or the outcome of the computation needs to be displayed back into your graphical user interface. Then it should be carried by some variable. So any such variables needs to be declared. Hey, I am string variable. And then you need to organize in this way using grid and labels, entry for user input, bottom, So you have a label, entry, button. And then finally main loop. What is the function main loop does?
Run the open one.
Main loop is the function of basic window, which is the window that you create here. But if you use Tizer, for example, then Tizer itself has main loop internally. So once the main loop is running, then Tizer doesn't want you to do main loop. There's not the language paradigm, but that is the Tizer issue, Tizer implementation. So if you, in that way, if you have GUI implementation in Tizer with no main loop to run it in some other environment, for example, command line environment, then it may not work. But in language, in syntax-wise, main loop is needed. What main loop function would do is, once you have a graphical user interface, and therefore user plays, and every time user plays, you have to rerun yours, right? You should continue to execute like a loop. That is simply what it does. Okay, so class is needed in class is part of object orientation. Have you learned any object-oriented languages? Java, C, then that is an object-oriented language. Almost all languages right now is object-oriented language. Although you do not care much, but there is some thing about object orientation. Particularly Python. Python is fully object-oriented implementation. Without knowing object orientation, still Python runs. But if your Python programs becomes complicated, then it should have object orientation. So I'm going to give you quick information about object orientation. Okay. When you say object orientation, then we have a class, object, and method. Class, object, and method. Class is the definition about all the objects within that class. Okay. For example, if you have a class called table, then there are so many different types of tables available, right? They're all called the class. They're all in the same type called same type called table. So table is class name. So that class tells us the definition about all individual tables, right? Any specific table is nothing but an object. The definition about all kinds of tables is called class. like a student, then you can say, oh, we have so many people available, right? You can say, I can define class called student. So I define the students. According to that definition, we know that, oh, this object, this human is a student, so that human is a student, so that human is a student. This human is not a student. We can say that, right? In reality, the object orientation becomes reasonable by using some concept. When I'm talking about now class and object, definition or distinction between class and objects. Let's say students. Martin, Vishnu, you are the students. So I call you first exist, right? You are not created based upon student definition. In the real world, you are not created because there is a student class. The real world is that if we want to speak about class definition, then we need to think about classification concept, so that I can classify Vishnu and Martins. Therefore they are students. So student is not really something that exists, but something that we conceptualize, right? In the real world, objects are the reality. Class is something that we conceptualized. That is the real world. Computer science, programming, it's not real world. Although we need to describe about the real world, but computers doesn't start from the same structure as the real world. Now you know the real world structure, right? Computer world structure is in this way. We first define class. Because anyway, in the computer, there's no class, there's no object, no nothing. Now we need to start from scratch. So which one is better? First create all the objects and then classify? No, that is too much work, right? So simple way is that, let's define class called the students. Students definition. And then we can create Vishnu, Martins, whoever, whatever, right? It's a lot easier and a lot straightforward, and that is very well structured.
So
That's a computer world.
So we can use it in the future if we want to class.
Right. So in the object-oriented programming, we need to define class first. Okay? As you define class, only the technique that you may need is encapsulation, which means how can we encapsulate the information about students? So that student has a student ID, student has a student major, student has some academic level. So first year, second year, third year, fourth year, fifth year, sixth year, whatever, right? That type of things. So we encapsulate all such basic information, and then we create class. Based upon that class, then we can now create each objects, as many objects as we want. Once you have one single class, then you may have multiple objects, hundreds of objects, or thousands of objects. Say, class called Mercy Cybersecurity Students. Then we can have Vishnu, Martin, whatever, whoever, right? We create 135 objects. It is called instantiation. Based upon class, we can make instance, right? Instance. So instantiation. Like this. We can say class called security. This is a class definition. And then we define, this is reserved, underscore, underscore, init, underscore, underscore. This is a constructor. This method is for object construction, so that this class encapsulate, this class security encapsulate device name, input and output. Okay? Device name, input and output. Of course, in order to do that, you have to have here no, you don't need to declare. In other programming language, then you need to declare your device, input and output, and then you need to say that. But in Python, we don't need to. But in this way, what this class encapsulates is device, input, and output. You can name it as you wish. Then there are all the components that can constitute a class called security. Okay, this is a reserved word. So we did encapsulation and instantiation. If you want to do instantiation, for example, I want to instantiate, this is instantiation. I want to instantiate security, this is class, same class name, right? Security, but in particular instance, I would say device name is Ubuntu, and input is keyword, and output is terminal. So we can send according to what it expects for object construction. It expects 3. The first one, self, is not really the parameter that you transfer.
Well, it has to be there.
It has to be there, right, in Python. So that device, input, and output. So 3 parameters come. So that when we call this function, we didn't call any, say, init here. This is a default. As far as you have underscore, underscore, init, underscore, 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 then this function is activated when this class is called. See a class? When this class is called with the parameter, with the parameters as defined in init function, this function is created. This function is executed. The output of this function execution is instantiation, which is an object. So that is created. Object is created by this. And that object is assigned to this, Linux. So Linux is an object name. So next time, oh, I want to go back to object called Linux. Like, oh, I want to go back to Martin. Then how can I, when I say Martin, then my verbal spoken character, Martin, is not really you, right? Martin is you only if this Martin has some of this equal sign. When I say Martin, then denotation comes to you, then Martin is you. It's called labeling, right? So label to yourself is called Martin. label to whatever object it is, whatever object which is constructed by this value Ubuntu keyboard terminal is now called Linux. So that we have objects created. Okay? So class and objects. What is the beauty of this? Can you do your programming without that object orientation in Python? Of course you can. What about the efficiency? Less efficient. Why? Unless otherwise, then you, every time you have a Linux, Ubuntu, whatever, Windows 7, Windows 10, Windows XP, then you have to, every time that, then you have to create this. And not only that, it is inefficient. In this case, you define first, define once, and use many. Otherwise, you have to define this at every single time if you don't do object orientation. Not only that, we need to have some behaviors of class. There's no behaviors here. Behaviors means some action, right? Somebody said, oh, Vishnu's behavior is so nice. Then what does that mean? His last name is so nice, or first name is so nice, or the food that he eats is so nice? No. His action is nice, right? So some action needs to be defined. So far, they are not action. They are something associated with Linux. There's a static information. It's declared in class and in objects. When you define class, if you want to define also some behaviors, then this object has that behaviors. If you are an object of students, and students' behavior is that you need to keep your GPA 3.0, then because you are an object of that class, because that class has the behavior requirements, therefore you should meet that requirements, right? Automatically. That is another beauty of object orientation. When you declare a class, when you define a class, if you define all kinds of behavioral definition, implementation, okay, once you have that class definition, after that, for any instantiation, for any object constructed based upon that class, can have the same behaviors. How nice it is, right? Once defined, many instantiation, many implementation. You don't need to implement for each individual because you are in that class, and class has that definition. So you are automatically have that implementation. That's object orientation. Beautiful, right?
So the object is just like a member of the class, right?
Exactly.
Okay. And the method, you have to define it.
The class has defined it. Of course, a programmer needs to define it. When a programmer defines a class, he should define a method also. As many methods as you want. For example, students, then calculation of GPA. Boom. What are the methods that you need? Tuition calculation. Boom. What others?
Test scores.
Right, registration. Okay. And then transcript. There's so many behaviors. And then job hunting. Finally. Yeah, you name it. So, we might have more methods. There is a predefined method and user-defined method. Predefined method is something like this. Init. So this is a method for construction. And str, this is a method for this up to here, right? This is a method for anybody had some knowledge about Java? No? No, nothing? Little bit of Java? Then this is a string of, this is the method called toString. Small to string. This is similar to that in Java.
I've learned something like constructors.
This is a constructor.
Yeah, the first one.
First one is a constructor.
So we can write up to 4 strings or something.
Right. Because it is a constructor that we can construct in this way. By sending 3 parameters as it waits 3 parameters. And then when you say print Linux, I simply say that objects. I didn't, when I say print objects, Linux, what does it print? In that case, it prints according to the defined in this __str___ open self close parenthesis. Whatever the implementation inside is this implementation. Oh, wait a minute. Here, it is up to here. We have another definition. This is a set on another methods. This method is, these 2 methods are it's not really predefined, but the name itself is predefined. The method name. You cannot change that method name. If you want to define the how an object is constructed, then it should be defined in __init__. If we want to implement the printout methods, that method is executed whenever the object itself is called, then you need to do __str__. Open parenthesis self and close parenthesis. Then simply, if you do this, then it works. Another one. This is a totally a different method that you need to define from scratch. Only what you need to do is def. This is a reserved word, def. And then set on, this is your name, and open parenthesis self. Self comes always first. Comma, month, and close parenthesis, and then colon. After that, the implementation of the method. Implementation in this case is only the print statements. That is called, this is called in this way. When you say this, Linux is an object of security. Dot, we have dot notation here. And then method name. This method expects month, or whatever that is. We say top. Okay? Then that is executed. When you say this, print Linux, print an objects only, then internally it executes that. If you have this instantiation, that internally it executes this. That's what they are doing. Now we have to practice, right? Let's practice. What I ask you to do is to I think Pfizer is okay here. Okay, so we have a Pfizer. Let's create a new by holding down Control button and N. Then you have new here. Let's create a class definition so that you have a class as we did the security. And then first definition is construct, so that init, and then self. Input parameters say device, and then input and output, colon, and then implementation for that is self device equals simply device, and self input equals input, self output equals output. Okay, let's do that for a moment, and then we can save this. Control S for saving, so that you need to go back to the workplace here in class, so that I have, for example, my first class called sec.py. Okay, so if I execute this, Control Enter, nothing. Nothing means I didn't do anything. I just create a class. That's it, right? So you need to figure that out. For example, oh, I want, because I have a class, I want an object. The way that I can construct an object is by calling class name itself, right? So that class name is security. When I call my class name, then when I call this class as a function, this is a class. It's not really function, right? Function means open parenthesis and close parenthesis. This class itself is not function. If we have a function, then this is like a function definition. This is a class definition. There is no parenthesis. But when we call the parenthesis, then instead of executing class itself, when you have this, then it executes init, this constructor. In order to execute init, which is a constructor method, then we need to match the parameter. This requires 3 parameters. Self is default. 3 parameters. So that we need to send this specific value. Say that Ubuntu. First parameter and input, say password. And output, say terminal. Okay? Save it and hit Control Enter so that execute it. What happens? So far nothing, right? Didn't do anything. Because why? Internally it has something about these objects. Can I see this object? Because in this way, object is created, object is constructed. That's what we learned. Can we see it?
Not yet.
No, we cannot. Because there is no label that you hold it up, right? In order to attach the label, then you need to assign this object to and one variable called, let's say, Linux. Okay? After this, if you say, what is a Linux? Then there's a something. Oh, Linux? Oh, there is some something. We do not know what it is, but oh, there is a something. You can create another security object, say Windows 10, Windows 10, Windows 10. Windows 10 can be constructed by calling security constructor. For the device is HP, and input is micro, and output is dummy. This is just in dummy, right? And the construct. Let's say, is there really Linux available? Oh yeah, as before, it is available. What about Windows 10? Oh yeah, there's an object. What about Windows XP? No, because Windows XP is not defined. It's not constructed, right? So we can say this is default constructor. This is object instantiation. This is a default constructor. Another thing that you could do is diff underscore underscore stl underscore underscore and self, and then you can say return you can say thank you for visiting me. Thank you for visiting self.device. And then format for the string self equals self. Okay. So we construct that. And for example, if you want to do, I want to print, see here Linux, so that is small linux, then there is a Linux. But if you do print Linux, then it says, thank you for visiting Ubuntu. When I do Linux, then I may be able to see some ID of that object. It's called the object ID. But when I print that object itself, and because I defined this is default method which is executed when an object is called. Okay? Look at the comments. When you say this, the default method which is executed when an object is called. See, object is not called, object is printed. Yeah, called and printed. So object is printed, then it returns, thank you for visiting, and then it says self-device this. Whose device? Whose device is it? This is a Linux device. What is a Linux device? When I come here, Linux device is Ubuntu. See here, thank you for visiting. Instead of this, Ubuntu. And format, self equals to self. We can put here more. For example, Ubuntu, that is shown on self dot output. So I run this, and if I redo this print Linux here, print, what is the output of that? This print Linux. Thank you for visiting Ubuntu. That is shown on terminal. Bingo. You're good. Go home. Now you know an object orientation. But this, and this is a default. Can you create something on our own method? Of course, you can do as many as you want, right? By having def, and what do you want to with this security device?
ID,
status, security status, which is good, right? Status, you can send status level, and then you can say print Okay, so that you can do here, for example, Linux dot status, open and close parenthesis, but this guy wants label, right? So that you need to put some label, say good, and enter. What did I do? Linux. Oh, no, self. Why this out? Self. And then if I do this, then it says Ubuntu is good, right? If I do Windows 10 and status, if I say bad, it says HP is bad. Things like that. So you can put that here instead of that. So all the statements that I demonstrated here included in this code altogether. So when I execute this, then it says default display by printing object. So that the first one is thank you for visiting Ubuntu. That is shown on the terminal. That is from this. And then the other print statements. Thank you for visiting HP. That is shown on dummy. And then next one is UDF. User-defined function is executed by calling object.method. That is here. And the first one, Linux.status. This is an object and this is a method. Dot in between. And this is a method, therefore this method is waiting label. So label is given. Very good. Therefore Ubuntu is very good. That is the output of this statements. And the other one is good. So Windows 10 dot status. This is an object. This is a method. This is an argument to this method. Therefore, this method is executed. Self.device, which is HP, is, and then label here. Okay. Any question about That's more precisely, if you want to see this, I would like to do in this way. And then Windows 10. I would do it like this. It looks very funny, but okay. This explains everything about this. Default display by printing object. For example, if you do print this, that's what we did here, right? Returns, thank you for visiting Ubuntu, that is shown on terminal. And another, if you do this, actually that's what we did here. Returns, thank you for visiting HP, that is shown on dummy. The next one is dash times 5, so 5 dashes. And then UDF, user defined function, is executed by calling object.method. So for example, linux.status open, and very good returns, Ubuntu is very good. And this returns HP is good. Alright? So I want you to take a look at this, and let's have a 15-minute break. And if you have a question, you can ask a question when I come back. So next homework assignment 2 is exercise 5.3, right? So that you need to make this. I'm going to give you a demo so that you will get some idea. Oh. Okay. So this is command line based. Okay, so that I can call Python 3.6, Python and temp conv. I'm going to run this program. Conv gy underscore 5. Okay. So it comes out like this. So basically we have top frame and mid frame and bottom frame. In the bottom frame we have two subframes, and for example this subframe has a button on top, and then there is an output. So if you put here some number, what is the temperature today? 14? 14 in Celsius, right?
No, but it's in Fahrenheit.
It doesn't matter. 14, if it is Fahrenheit, then 14 in Fahrenheit will be negative 10 in Celsius. If it is 14 Celsius, then 57 Fahrenheit. I think this is the temperature right now, right? 52. The 57? Then it should be more than 14 in Celsius.
It's 14 degrees Celsius. No.
Yeah. So that is this. This is the second homework assignment. What I want from you, I want to source code which do not require any additional modules. I do not want to. So basic idea is this: do not use any other external modules. I want you to use simply tkinter. Okay. The version earlier than this appears the way that you can create, that is this. I think this is what we did the last time, right? So that you have this is simpler than the one that we had in the last class. Source code is here. This is what you know already, and then the other one that you know already is here. Something that we did first time of this, right? You already had this, so you do not have any problem. Only if you want to see. So earlier video slide tells you some of this. Right. So I'm going to close this. So today we'll look at, we might have about 40 minutes. We'll look at the menu. So this will be your next homework assignments. In the menu, we will learn how to save files, how to retrieve files, and so on and so forth. So let's try sum. Okay, so I think we need to practice. In this case, I'm going to use rather than tkinter, I'm going to use what do I need to use? Rather than tkinter, I'm going to use notepad. This is notepad. Notepad is just an editor, so you can, if you have a Paizo running well, that's fine. But in general, we can do this. Okay, so from, I think I need to make this a little bigger, right? So I'm going to do format, fonts, 14. I think this is better. From tkinter, import everything. Then we need to make first basic window, so tk, and then we'll make a frame, so frm, that is a variable to hold the frame. This frame should be inside the root, and then width is 400 and height is 400. Let's make a little bigger the width, say 600. FRM, that's frame. And then we need to make an editor. That is another, that is a text. Text is in root. No, text is in frame. Frame. FRM. And then root title, call the text editor. And then we need to make a menu. So my menu equals menu, that is in root. And then first of all, file menu, man equals menu, which is in my menu, and then tier of equals 0, file menu, we need to add the command. And label, say new. Equals open. Equals save. We save this. Save it. In class, say myeditor.py. So if you run this, myeditor.py, it appears like this. But yet, there is no I think I did width 600, height, yeah, a little bit over muscles and needed. So one another thing that we need to do is here, my menu add cascade label equals file, and then menu equals fileman. That is not there. Then this size needs to be fixed that way, so FRM pack propagate 0 FRM pack expand yes fill both, so that frame can be expanded fully. So that it'll come like this. Previously, frame within this basic window root. Although we have this size with the 600 height, 400, it is not really fully expanded both left and right. Therefore, we have very small ones here. But this is 400 width and 600 width and 400 width. That's full. The frame here expanded that way. And this menu, see here, and also inside this is editor, right? But if we have it here, when I click File, then I have sub menus, right? The one that I had here. This is a menu. Menu is in root. First menu is File. My file menu. My file menu has 3 sub options: New, Open, and Save. That's what I had here, right? New, Open, and Save. And then this whole thing is cascaded within this file. It's called file there. And this menu has file man. So under this label, we have this sub menus. That's what I have here right now, right? But there is no action, anything at all. If I type, if I click anything, nothing executed because we didn't do anything, right? We simply make a menus, and we can create more and more menus, but we don't do here yet, right? So I wanted to do up to that point. So what happens here is that we have a basic window which contains frame, but I set the frame size and expand to fully both left and right. That's what I did here. Not only frame, but we have also menu, right? So we have a menu. There's first menu label is file. Menu is called file man. The file man has 3 commands added: new, open, and save. That's what happens here. If you add more here, for example, file man and add command label equals exit. But in between, if you want to make a separator, then that is also possible. So if I save that and run again, as we look at here, if I click file, then there's a separator. See here, separator, and then exit. That is the way that I made it, right? That is possible. Action will be done soon. question? Martin, doing well? Good. Next thing that we need to do is, for example, if you want to open a new file, then we need to create a method and the function. So command equal and the function name here, so that we can say open file. And then that function needs to be defined. So def open file. Okay, so in this definition of open file, what you need to do is to ask open file and mode equal all. All is just to read, right? That is what we want to open. And I want to, when I do this, ask open file, I need to have import that more specifically. So from tkinter dot file dialog import ask open file. This ask open file is the it's a module that we open it, right? It's like a class. It's a class constructor. Okay, so we save this and run it. Then we have dialog import. There's no module name. Tkinter. So when it comes here, then when I open this in this program, when I click open, then click that and choose. If this menu is chosen, then open file function is executed. So open file function is this. Right now, when it comes to this function, it has another constructor. So that when I call here, then it opens this, so that it asks me to choose one of these. So for example, if I choose this, open, then nothing, right? Why it doesn't do anything? Because we didn't do anything. We just simply choose. We didn't do anything. For example, when I select that file, then I need to hold that file. Say F equals. Then when that file is selected, then this is the file that I want to cook with. So how can I cook? So here, that should be a file, right? So if F is none, so nothing is chosen, then we simply say don't do anything, simply return. Else, if a file is chosen, then we need to do we have to read that. F need to be read, and then that should be written in this editor, so that we can say editor dot insert. That should have insert mode and that. Okay, see what happens. Here, when I do open, I can click one of text file, open, but it is not shown. One of the reason is this is not converted to string, so that we can do str for string. Whatever read should be converted to string. And then another possible thing that we need to make sure here is this editor should be also the way that we did here, right? So instead of FRM, we say editor. Editor should be also expand fully within that frame. So open and whatever file, therefore that is the comes up here. Okay. When I do open another, then something should be come here, but for example, if I open another one, create canvas, then another one is attached, right? So what we need to do is when I open, then we need to clean the previous ones and then override it, right? In order to do that, not only insert, but before we insert, we have to editor and delete everything there, so that the way that we delete the entire is this command, so that when I run this again, open, first I click this file.txt. Oh, that's not there. So open web to text, then that is that. When I click something else, temperature file, then something came up, right? It's different. So when it comes up, then rather than append to the end of that file, I want to clean up first. which way that I can clean up? I can clean up this. Editor, delete everything, and then I insert whatever I do have, right? So another example, maybe some animation, some other animations, right? Animation files. So this is what I ask you to do. Right now we have only open, but you need to make a new, save. New is rather simple, right? You need to make a open space, which means simply delete it and ready for. So we can implement it quick. For example, new editor. Then we can do here df new editor, and we can say editor delete 1.0 end. How about that? That is a new. So up here, so open the file is, oh, that's a 0. That's why previously we have. So that is open. So if you do new, then clean space. If I open something else, then that came up. Another. And new, clean up. Save, not implemented, right? So we need to make save implementation. So here we call save file. Then save file is similar to this open file. Tab, save file. Save file. The one that we have is very similar to that. Ask, see here, ask open. What would be the name that we need to call instead of a save open file? We need to have save, ask here, ask open file. So similar to that, we need to have ask save file, right? So we need to import that here from tkinter file dialog, import ask save as file. Need to save as file. Save, where is it? Save as file. And the mode equals not read, not like this, but we need to have write. Mode is write. And then if you want to do default file type, then you can say default extension, default extension equal f.txt and close. Same thing, if f is none, simply return, else we need to do f dot write, and then the one that we need to get from editor. So editor dot get, editor is the editor that we use, right? This is editor. So we need to get editor 1.02 end. That's what we want to do, and after that file is closed so that it is completely saved. Okay, so let's see what happens. Tap save file, have a colon. So we have this, and we can have, for example, this open, and then we can say here, we can type this. Hey, this is fun, and make this. Today is February 23rd, 17, and time is 5:21.
Hello, Professor.
Hey, Hama.
How are you? Happy
We're
New
taking
Year.
much. Happy spring. Happy spring. Take a seat. Take seats. Oh, UN delegate. Take seat. That is your seat. So we edited this, and then we save it differently. So save, then it asks me to save, right? So that I can do, this is not what I want, where I want to save. I want to save it in class. So I have it here in class. The one that I picked up was, I think, I don't know, maybe test to save. Okay? And then save. The way that I need to test, new, and when I open, to see if there is any. See here, test to save. Just right now. And when I open this, to see if it is that. See? This is that I made, right? That I edited. So it is saved and returned. Alright? Question. This is it. So I wanted to practice this, and I'm going to stop it. Okay?